Hello and welcome back. Today we will be talking about percentiles and percentile rank. Students often confuse the terms percentile and percentile rank, but they answer two different questions. Percentile answers the question, what value is located at a certain percentage of the data, while percentile rank answers the question, what percentage of the data is at or below a particular value. And I want to highlight this because the at part is important. Quick way to remember it, percentile, given a percentage, find a value. Percentile rank, given a value, find a percentage. Okay. I want to talk about this because you hear about like you know, the 20th percentile, the 70th percentile, you hear that kind of language very often. So I just want to talk about like what exactly that means and how we can calculate it. All right. So part one, percentiles. A percentile is a value that marks a location within an ordered data set. Important examples, the 25th percentile is the first quartile, which is denoted as Q1. The 50th percentile is the median. And the 75th percentile is third quartile or Q3. My video on box plots covers the quartiles. I might have another video discussing the quartiles, but immediately the box plot one comes to mind. So if you need a review on that, I would recommend checking out that video. All right. Examples. Example one, find the 70th percentile. Okay. So here's our data set, and it is given to us in ascending order. We always want to make sure our data sets are in ascending order. Our first step is to find the position. Okay. So the position is given by this simple equation. The position equals the percentile that we're given divided by 100 times the number of observations. Okay. So for our example here, we could write them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are given 10 observations. So we will use 10. 10 is the number we multiply by. We're looking for the 70th percentile, so that goes in the numerator here. 70 divided by 100 over 10 gives us 7. So the position of the 70th percentile is our 7th position. Okay. Step 2, locate the 7th observation. I have them listed here again. 1, 2, 3, 4, 5, 6, 7. The 7th position is 72, so the value at the 70th position is about 72. So you could say if your score is 72, you're in the 70th percentile. Cool. Clean that up. Okay. Another example, looking for the 90th percentile. Oops. Again, here's our ordered data set, same set as before. We're looking for the 90th. Okay, so we find the position, our equation again. Our position is 90 divided by 100 times 10 observations. This gives us 9. Okay, locate the 9th observation. Here I have the number. The 9th observation is 78, which means the value at the 90th percentile is 78. Easy enough. Okay. Just a quick note here. Different textbooks and statistical software use slightly different formulas for locating percentile values. In AP Stats, use the method specified by your teacher, textbook, calculator, or exam question. Okay, this is one of many methods. Typically, software is given for this. Just use that. If you don't have software, this is a very easy way to do it. Okay. All right. Part 2, the percentile rank. The percentile rank tells us where one observation stands compared to the rest of the data. So we find it with this equation given here. Percentile rank equals the number of observations at or below our given value divided by the total number of observations times 100. Okay, let's take a look at an example. Find the percentile rank of 72. Okay, step 1, count the number of observations at or below 72. So you see I have a note here. We're going to start at 72 and count down. 72 is 1, 2, 3, 4, 5, 6, 7. There are 7 observations at or below 72. And then step 2, we plug it into our equation here. I rewrote the equation. There are 7 observations at or below 72, so 7 goes into our numerator. There are 10 observations in total. We divide by 10, divide or multiply by 100, our percentile rank is 70. So 72 is the 70th percentile, which we should have seen from our first example up here. Yep. 70th percentile, 72. That's just the inverse way of doing it. All right. Comparing the two. Percentile question, what value is the 90th percentile? We find the value. Percentile rank, what is a percentile rank of the value? In this case, 78. It's the 90th percentile. Again, another example of how they're inverse to each other. Some common mistakes, mixing the two up, confusing percentiles with percentile ranks. Looking over here, there's a little trick that helps me remember. Percentile associate with you're given the percentage, the P and the P, okay? Percentile given percentage, PP. Percentile rank, and just remember it's the opposite one, okay? So if you can associate percentile with given percentage, it's easy to remember that, okay, percentile rank is given value. Some other common mistakes. This is a huge one I see all the time. Thinking the 90th percentile means a score of 90%. No, it means you're at or above 90% of the data. There's a joke where uneducated folk will think like, oh, I'm in the 10th percentile, and they think that means they're in the top 10. Wrong. It means they're better than 10% of the data, which actually puts them in the bottom 10%. Okay. Forgetting to order the data, we must be mindful, always put in ascending order. And assuming every calculator uses the same formula, I wouldn't stress too much over that last one. Cool. And here we have some practice problems. Our order data is given here in ascending order, and our questions, 2 for percentiles, find the value at the 40th percentile, and find the value at the 80th percentile. And percentile rank, 2 questions here, find the percentile rank of 44, and find the percentile rank of 72. I will give you a moment to pause the video here and take a stab at these questions. All right, hopefully you did that. Let's take a look at the solutions. So the first question, find the value at the 90th percentile. Okay, so, I'm sorry, at the 40th percentile, my mistake. Here I gave the data. I rewrote the equations again down here just so we can have them as a reminder, but we do the 40th percentile divided by 100. We multiply by 15 because if we count here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 observations in our data set. Okay, so 40th percentile divided by 100 times 15. We do the math here. That gives us 6. So we know the 6th position is the 40th percentile. We count up 1, 2, 3, 4, 5, 6. At position 6 is the value of 40. Therefore, 40 is the 40th percentile. Next one is the same thing with the 80th percentile. So we do 80th percentile divided by 100 times our 15 observations. Do the math there, we get 12. Okay, so now we find the 12th position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We see 67 is at the 12th position. Therefore, 67 is our value at the 80th percentile. Okay. All right. Next question is find the percentile rank of 44. Okay. So 44 is right here. We count how many observations are at or below this point. 1, 2, 3, 4, 5, 6, 7. So that's where the 7 in our numerator comes from. There are 15 observations in total. 7 divided by 15 times 100 gives us roughly the 46.67th percentile. Because there's the percentiles, you can safely round this up to the 47th percentile. That's fine too. I like decimals because it's a little bit more accurate. This number's really closer to 46.5 than it is 47. But, you know, we're arguing pocket change here. All right. And the last question, find the percentile rank of 72. Okay. So 72, there are 13 observations at or below 72. So that's where the 13 in our numerator comes from. There are 15 observations in total. 30 divided by 15 times 100 is roughly 86.67. Therefore, it is the 86.67th percentile. Cool. And that is everything I have for you on percentile and percentile ranks. Thank you for tuning in. As always, a link to the notes will be in the comments, or sorry, in the description. And I will see you next time. Take care.